All right, so the first thing we're going to do is we are going to take a look at this first part, these main ideas. So let's first talk about isosceles triangles. So it says the two congruent sides are called legs. So if we were going to mark this, this would be a leg, and this guy would be a leg. The angle where the legs intersect is called the vertex angle. So they're talking about this guy right here. That's your vertex angle. The opposite side is called the base. So they're talking about AC, that's your base. And then the angles along the base are called the base angles. Hi. The note sheet is on top of the file cabinet for you. So in this case, we're looking at 2 and 3. Those will be known as base angles. Now, it says the isosceles triangle theorem. So you guys remember when we did parallel lines cut by a transversal? If we were proving angles, we had the theorems or postulates themselves, and then we were proving lines parallel, we had those converses. We have the same thing here, okay? So if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So what we're saying here is that if we use this triangle, if AB, this guy right here, and BC are congruent, then angle A and angle C are also congruent. And then the converse, it just flips it around. If two angles are congruent, so they're saying if you're given angle A and angle C are congruent, then you would know that AB and BC are then congruent. Questions on this? Is anybody still writing? Okay. All right, so let's take a look at number 1. Okay, so we're going to just identify each angle measure that's missing. Okay, so these are our isosceles. So K is our vertex angle. So I'm just going to mark that with a little vertex. That means J and L end up being congruent. So that makes angle J 68 degrees, while the measure of angle K is going to be 180 minus 68 minus another 68. And what does that give me for angle K? Good. 44 degrees. Okay. For letter C, they're giving us this vertex angle. So D is the vertex angle, which means angle C and angle E will be congruent to each other. So whatever we get for C, we get for E as well. So I'm going to take 180 and minus 106 from that. What does that give me? Take out your calculators. Those are going to be super helpful. It is. Good. What's 108? What's 180 minus 106? Good. 74. All right. And then we're going to take that and we're going to divide that by 2, which gives us 37 for each. Okay, so this is 37 and this is 37. All right, so these two angles are congruent, so we're going to apply that converse of the isosceles triangle theorem, which makes this congruent with this, so YZ ends up being 12. And if we look at the measure of angle Y, we're going to take 180, subtract 77, and subtract 77. So what do we get for the measure of angle Y? Good. 26 degrees. Very good. All right, questions on that? Okay. Let's apply a little bit of algebra. So what they're telling us here is that we have 5x plus 9 as this angle and 8x minus 30 is this angle. What do we know about these two angles? They end up being what? Congruent to each other. All right, so I am going to now set them equal to each other and solve. So this will be 5x plus 9 equals 8x minus 30. I'll subtract the 5x from each side. That leaves me with 9 equals 3x minus 30. I'm going to add the 30 to each side. I don't know why my color didn't change, but that's okay. This leaves me with 39 equals 3x. Divide both sides by 3. So now I get x is equal to, in this case, 13. And that's what we're looking for. Now, if I wanted to solve for each angle, I would take the 13 and I would substitute it in. Okay, but I don't have to do that for this one necessarily, but just keep that in mind. Why don't you guys try number 5 on your own? Someone tell me, what does x equal here? 8. Does anybody need to see this? Okay. All right, let's take a look at number 6. All right, so number 6, they're telling us, hey, we have these congruent angles, which means these sides are equal to each other. So we're going to have 15x plus 7 equals 23x minus 17. I'm going to subtract the 15x from each side. This leaves me with 7 equals 8x minus 17. And then to add the 17 to both sides. So I'm left with 24 equals 8x. And I'll divide both sides by 8. So here I'm going to get x is equal to 3. Again, if I needed to find the side lengths, I would take this 3 and substitute it in for each. Now for number 7, they're telling us that 74, that this angle and this angle are congruent, making these two sides congruent as well. Why don't you guys solve for that one? All right, who's still working on 7? Who has x for me? What does x equal here? Go ahead. 16, nice job. Does anybody need to see this one? Yeah, okay. So all we're gonna do is we're gonna set this up as 3x plus 23 equals 9x minus 73. I am going to subtract the 3x from each side. That leaves me with 23 equals 6x minus 73. I'm going to add 73 to each side. This leaves me with 96 equals 6x. And I divide both sides by 6, leaving me with x equals 16. Does that help? Any questions on this before we move on to number 8, or in general that I can address? All right, let's take a look at number 8. So 8 says in triangle RST. So I'm going to draw a triangle because there's nothing here. Triangle RST. They're saying RT is congruent to ST. So this is congruent with this. So those are my two side lengths. So that means this angle is congruent with that angle, and I have the two side lengths. So they're saying the measure of angle R is 9x plus 2. So right here is 9x plus 2 degrees. The measure of angle S right here is going to be 13x minus 18. And they're telling me the measure of angle T right here is going to be 17x plus 1. They want us to find x and then each measure. Which two angles do I need to use in order to find x? Because that has to be your first step. Which two are going to work? Which two angles? R and S, S and T, T and R? Which ones? Good. Not R and T. Yeah. S and R. Very good. So we're going to set the measure of angle S equals the measure of angle R. So this is going to be 13x minus 18 equals 9x plus 2. I am going to subtract 9x from each side. Which leaves me with 4x minus. Come on. Here we go. Minus 18 equals 2. I'm going to add the 18 to each side. This leaves me with 4x equals 20. And I'm going to divide both sides by 4, so I get x is equal to 5. But I'm not done yet. This is a substitution problem. They didn't ask just for x, they asked for all those angle measures. So I'm going to first substitute this 5 in for angle R, which will be 9 times 5 plus 2, which gives me 47. So angle R is 47 degrees. Now, if angle R is 47 degrees, then angle S is also what? Because we said those two were equal. So what is angle S? 47. And then I'm going to take this and substitute it in for angle T. So this will be 17 times 5 plus 1. And then 17 times 5 plus 1 leaves me with a total of 86 degrees. I want you guys to try number 10 on your own. Try number 10. Because 10 is very similar to number 8. Just skip 9 for right now. Just try 10. No, I didn't say that. I just said try number 10. Try number 10 on your own. What are we doing? Any questions? No, you don't. You understand it? Gentlemen, any questions? Cute fish. Very cute.
I thought there was me.
Don't know. Just no. It looks like a fish to me.
It doesn't breathe air.
The fin. The fins. See the fins? That's a side fin. That's the top. That's the back. Maybe. I can see where you're coming from. Kinda. I can see where it's coming from, but it looked like a fish to me. An alien fish. Oh, okay. We'll do half. Oh, it's a very angry fish, but it's still a fish. Remember working on 10? So, 10. Yeah. You guys have any questions though?
No.
Dear, ladies and gentlemen, any questions over here? Was really for a math question, but. Oh, no, I don't. Oh, you guys will. So we're saying WX is this congruent with this. So that means these two are congruent. Ladies, any questions like this? Anything here? Questions? I forget
Oh, you can smoke it.
It's easy, that's good. What's up? So WX, this is congruent with W1. So those two drives and those angles. So that makes this guy the vertex angle. Well, these stuff is equal to each other. So if we're saying W is that, this is 5x minus 2. And this is 7x minus 48. Yes, that is equal to each other's self drives. Hi. You okay? How are we doing on this? Left leg? Left leg? Forward? Nothing. Forward. Left leg. So please. All right, how are we doing on 10? Ready to see the answer? Yeah. Okay. Uh-oh. No, don't do it. Oh, I did it. God forbid. Okay. Come on. All right, so here is 10. 18, 24, 78, and 78. Had bigger numbers, so I wanted us to work on that. Any questions on that? 9 is going to be the same thing. It's just dealing with side links. So that's why I'm going to leave that up to you guys if you choose to do it. Okay. All right, let's take a look at equilateral triangles now. So it says a triangle is equilateral if and only if it is equiangular. Equilateral means side lengths. Equiangular means angles. So all of them are equal. If the measure of angle A equals the measure of angle B equals the measure of angle C, then AB equals BC equals CA, or they're congruent, okay? If all the sides are equal, then all the measures of the angles are equal. So here's what you need to know. The equilateral triangles, this would be the theorem. Come on now. This would be the theorem. This would be your converse. Okay. So since we're at it, someone tell me, if we're talking about all the angles being equal and we know a triangle is 180 degrees, if I take 180 degrees and divide it by 3, what's my degree measure going to be? It's 180 divided by 3. 60. That means for all equilateral triangles, the angles are 60 degrees. All right, so let's take a look at our examples. So number 11, we have 60 degrees here, 60 degrees here. That means angle C is also 60 degrees. Nothing different. And since all those angles are equiangular, that means all the sides are equilateral. So BC will also be 9 feet and AC will be 9 feet. All right, now for 12, they're saying all the sides are equal. So that means all the angles are equal, and that means all the angles are going to be just 60 degrees. There is nothing more to do there. Sure. So number 13 states, if triangle PQR is an equilateral triangle, solve for X and Y. All right, so this is going to be a smidge different than what you're used to. If we're going to solve for X here, the thing I only have the one angle, but I know this angle is equal to what since it's equilateral? 60 degrees. So to solve for X, I'm going to have 7X plus 3 equals 60. I'm going to subtract 3 from each side. That leaves me with 7X equals 57. Oh, wait, I made a mistake, didn't I? Whoops. I did. This is minus, so this should be plus. There we go. So this should actually be 63, which makes a lot more sense. Okay, and then I'm going to divide both sides by 7, leaving me with X equals 9. So there's X. I can easily solve for that, substitute it in, and as long as I get 60 degrees back, I'm good. Now for angle Y, variable Y, you have some choices here. You can set, because this is equilateral, you can set any of those equal to each other. It does not matter which two you choose. I'm going to choose 14Y minus 59. I'm going to set that equal to 9Y plus 1. I'm going to subtract the 9Y from each side. This leaves me with 5Y minus 59 equals 1. I'm going to add the 59 to each side. This leaves me with 5Y equals 60. And divide both sides by 5. So then Y equals 12 in this case. So these are my two answers. If I needed to solve for the sides, I would just substitute them in. Okay? Questions on this? Okay, get going on your homework. It's the next 2 pages. Okay? Yes, I want pictures of this in Google Classroom. Okay? If you did not submit it from Friday, I do highly recommend you get it in this period, maybe towards the end of the period, because that is going to have a very quick turnaround time. Okay? Sound good? Questions? All right. That is it. Those of you watching at home, have a great day.